Hey there, Rustaceans. In part 1, we saw how to create a vector and add elements to it. Now that you got your data stored, what's next? You need to access it, right? In part 2 of our Rust vector series, we are diving deep into the different ways you can safely and efficiently access elements from your Rust vectors. We will cover everything from simple indexing to more advanced methods. We will be also looking into different options of removing elements from the Rust vectors. Make sure you understand the right tool for the job, so get ready to master vector access in Rust. Let's jump in. Let's start by a simple example. Okay, you have a 32-bit integer numbers which is stored inside this vector. Now you want to access the third element from the vector, right? Now this is the most unsafe way to access the element, because suppose the third element is not there in the vector, what will happen? So the code will panic. Let's execute this. You can see we get the third element. Now suppose this vector is empty and we are using the same accessing. So you can see there is a issue here. The code panics and you are getting this error. Now I will show you one way we can handle this. This is not a recommended approach. Let's go with the first approach. This is using unwrap or. Now in order to use this, you need to use the get method first, where you pass the index. And then on top of that, the next method is unwrap or, where you can pass the default value. Let's run it and see. So you see we have an empty vector, and let's run this code. You see the value is 0. The output we are getting the third element. Now let's add some elements to the vector and run the code, and let's see what is the third element. You can see we got the third element. The next pattern we are going to see is if-let pattern. So ideally we are expecting from the example here the vector v, either we will have a value or the vector there are no values. Okay, at the position of index of 2. Now to represent that, we have this if-let pattern, right? So it's an option, if there is a value that is represented by this sum variant, the print statement will be executed if the value is present. If the value is not present, basically it goes to the none variant and the else block will get printed. The scope of this value will be limited to this if bracts. Now let's run this and see. You can see we get the third element without any elements in the vector. Let's run it again. We see we get the else block printed out. So this is one of the safest way we can access the elements using this pattern. The next pattern is the match pattern. Before going to match pattern, how it is different from the if-let. In the if-let pattern, for specifically handling this option when there is a value, so we have the sum, and we used to print the if block. Now when there is no value, it would be none variant. The thing is, we have an else block there. It's not specifically handling none block. It is basically, it handles all non-matching cases. Okay, that's what that else is for. Now in the match pattern, you can specifically handle this none variant block. So you can see from the code, if there is any value, it will be a sum variant, and the sum variant arm gets executed. And if the pattern comes as none, the none variant block will be executed. There was just an else block where the none comes or any other condition comes, that else block would have got printed out. So that's one difference we need to keep in mind. Back to our code. Now we have the vector containing 32-bit integers. We'll execute this and see the output. We can see we are getting the third element. Now we uncomment the empty vector and execute it and see. So we can see it handles the none variant. This is also a common pattern, and I believe this is the most robust pattern out there to handle safely accessing elements from a vector. Now we will be looking into how we can remove elements from a vector in Rust. We have a vector containing 32-bit integers. Now the first method is the pop method. What does pop do is basically it removes the last element from the vector. Next is the remove method. The remove method, what it does is you can specifically mention the index from where you want to remove the element, and it removes the element from that particular index. Finally, you have the clear method. What clear does is if you have a vector, it will clear all the elements from the vector, but it retains the capacity. Now, if you want to know more about vectors length, vector capacity, we have a video for it. I'll link the video down in the description. Let's now execute this and see. Initial vector we had 1, 2, 3, 4, 5. Now when we pop it, we only now have 1, 2, 3, 4. There you can see we remove the third element. So third element from 1, 2, 3, 4 means the fourth index. So the fourth index is 4 obviously here. So it's 1, 2, 3. And after using the clear method, you have the empty vector, but we have the entire capacity retained. Next, we are going to look into two methods, retain and truncate. So these are mutating methods, or what they do is in-place modification methods. They modify the original collection rather than creating a new one. The return type will be always unit type, and it changes the vector's content or length directly. What is the purpose of retain method? It keeps only elements that satisfy a given condition. In our case, elements which are greater or equal to 3, it will retain only those elements. Whereas in truncate, it shortens the vector to a specified length. It takes a length parameter and removes all elements beyond that index. Now let's run this and see our output. You see we get 3, 4, 5. The condition has been met successfully. And for the truncate method, yeah, we have restricted to a length of 2. So we get 3 and 4. Now why we are getting 3 and 4, not 1 and 2? Because these are mutating methods. That means once retain happens, the vector v here becomes 3, 4, 5. And then you are operating on that vector, truncate, using the truncate method. Alright, Rustaceans, we have covered a lot in this video, from safely accessing elements in your vectors using unwrap or if let and match patterns, to efficiently removing elements with pop, remove, clear, retain and truncate. You are now well equipped to manage your vector data like a pro. But the journey doesn't stop here. In our next video, we are going to dive into another fundamental data type in Rust, which is strings. If you found this video helpful, give it a thumbs up, subscribe for more Rust content, and hit that notification bell so you don't miss out on the next one. Thanks for watching, and I'll see you in the next video. Happy coding!